Hello, hello, hello! Welcome everyone to this episode of the Julia Dispatch podcast. So this time we're going to try something a little bit different. We still got Chris and Mike here, but I think the difference is that we don't have a invited guest this time. We might do some invited guests for this series, but I think that one of the things that we want to do is we want to introduce a new series here, which was this month in the Julia world. You might have seen that there are these newsletters going around, such as this newsletter for Julia Hub and also for Julia in general, and they kind of capture different parts of what's going on in the Julia ecosystem. We thought it'd be nice to be able to take this information, put it into a format where we then kind of have this discussion back and forth to help people understand what's in there. Oh, and I just realized that we didn't actually complete the introductions. So I'm Chris Rackauckas.
And I'm Michael Tiemann. And not understanding things is perfect for me because I will probably not understand what some of these things are. But luckily for me, I have an expert on the show every time. And so I will be able to...
We didn't invite an expert this time.
Yeah, okay. No witty comeback available. Let's get right to it.
All right, let's get right to it.
Revise is almost ready to work on structs. I think I know what this means, but I haven't followed the discussion. So,
let me give a quick introduction to people here. So if you haven't seen like Revise.jl, right? If you're using Julia and you're not using Revise, you're crazy. Look into what Revise is. This is great, right? So Revise.jl, what it does is it lets you redo the package compilation directly. So let's say you change one function in your package. You don't need to close your Julia session, restart a new Julia session, recompile the whole thing, and run it. This package will allow you to just rewrite functions inside of there. And I'm not sure if there's like a very good tutorial to this, but I mean, it basically just makes Julia work and look interactive, right? Now, the issue with Revise in the past was that there are certain things that you could not do, right? So this limitations page, you could not make changes to type definitions or consts, conflicts between variables and functions sharing the same name, and removal of exploits, right? And so if you ever made a change to your package and you're just like, oh, let me change the name of this type, that it's like, oh, well, so most things, you just change the name of your function, you reevaluate it with Revise, and then you're back in your REPL. Everything works smoothly and nicely, right? This is one limitation, which is like, oh, I changed the name of my type. Well, I got to restart Julia, right? This is just a long-standing limitation since Revise was made. And what this announcement is saying is that there's the latest PR and there's been a bunch of updates, which makes it so that way, Keno's latest things allow you to basically swap out like your main module, yada, yada, yada. So that way it basically knows how to change types within the same session.
And that's very cool because if I understand the other limitations correctly, I mean, having the same variable name and function name, I would guess that this is also not considered best practice to have something with the same name there, right?
Like, yeah, well, so this is actually related. This is actually really related, right? Because the way that functions work in Julia is that functions are types, right? So if you know like the callable type syntax, right? You can define this type, and then you can add a call function to the type, right? And so the way that functions in Julia actually work is they just create a function with the name of like hashtag they create a type that is hashtag my function name, and they puts a call on that. So every function is just a type. So the fact that you couldn't, the fact that you had this issue with, oh, I have a function, now I try to redefine it as a variable. The reason why it couldn't do that was because it couldn't change type definitions because functions are types, right? And they're constant types. So actually these two issues are actually really linked, and I would assume that they kind of get fixed together just because they're kind of harping on the same internal issue there.
Ah, okay, that makes sense. But still, I would assume that you shouldn't have a variable and a function of the same name.
Oh, for sure. Yeah, I mean, if you have a variable and a function that are the same name, well, I mean, callable types are something that you can use, right? They are a variable, and then you can call them as a function. So, like data interpolations is a great example of that, right? Where you create this type, and it is instantiation of an interpolation, but when you call it with a value t, it is the function that interpolates, right? So I do think that there's use cases, and there's a lot of use cases for it, but I think that the key is, being able to redefine functions like you would redefine variables. It treated one set as constant types that you can never redefine in Revise, and it said variables, you can do anything you want with them. And that made it kind of funky to swap between them, right?
Yeah, right.
Okay, they were like two different worlds.
Yeah, I see. All right. And I mean, the last point with the removal of the exports, I would say that this is mostly something that, I mean, the way you use Revise, right? You check, did the 10 lines of code that I've just written do what I've expected it to do, and then you iterate, and at some point you will have a working package. And then removing exports is really the cleanup at the very end. And if you want to check whether you're not exporting something, this should be done by tests, unit tests anyway, to make sure, okay, did I clean up everything?
And actually, I think there's a package that I've been using recently for this. I think it's like implicit exports.jl or something, explicit imports.jl, right? Which is actually a really nice package for printing out and writing tests that basically just say, like, test to make sure that everything I'm exporting actually exists, and not everything that I'm exporting is public API, and then I have it in my documentation, right? So there's ways to automate this for these, for these packages these days. So I do think that, that's kind of like the last. I wouldn't worry too much about this. No, I think that one thing that people will still notice with Revise, right, and I think is almost kind of fundamental to a little bit of how it works in Julia itself, is that I don't think that it can actually get rid of dispatches, though, right? I mean, so let's say you define a function, you define a function on numbers, right? And then you revise it so that way you add you create a new, you go into your package source code and you change like : number to : int, right? Since those are two different dispatches, they'll actually add a new dispatch to it, right? And so then you have these two dispatches, and so your function will still work in your current REPL session on float 64s, even though if you're to then reload your Julia, it would only work on instant, right?
Yeah.
But I think that that's kind of difficult to figure out, like, should I be deleting a dispatch or something? So I think that will still be a limitation that you see. And I think, so some things people will be like, I changed my function, it's not working. You can kind of see if you think about it hard enough, like why you don't necessarily want to delete all dispatches or whatnot. So I think that there'll still be a limitation in here, but this is a pretty big improvement, I would say.
Yeah. That's really cool.
Yeah. And so then the next one is JET.ls.jl, which is a new language server with advanced static analysis for nation state. It's in the nation state of development, and there's a lot of Google Summer of Code projects that are related to this. But, so let me give a quick overview of what this is, right? So the language server is the analysis server that's built into IDEs, right? So like, for example, when you open up VS Code, it runs the language server, and this language server checks all your packages, and then the language server is the thing that computes that, hey, look, I have this issue like for this linting error, and hey, look, you might have a type instability here, right? And it's the thing that gives you all this kind of hints and completions and stuff, and it's what the VS Code is using under the hood for these kind of computations about what's going on in your code, right? And what this is saying is, so JET, I guess there's a bit of details in here. So JET.jl is a static analysis tool, which means that what it's able to do is able to look at things through inside of Julia's compiler and type inference to be able to make detailed discussions about what's going on with types, whether things are mutating, like all of these kind of detailed compiler level analyses, right? And so what this is saying is that there's a new language server that is able to use JET, so it's able to use these static compilation tools to potentially in the future give us better information, such as, is this function type stable, and be able to just kind of give that as linting information, right?
And so I'm guessing most people would interact with this in Visual Studio Code or their favorite IDE, right?
Yeah, I think that most people, this would look kind of invisible. Well, the way that you kind of see it is just like, oh, Visual Studio Code now tells me if my function's allocating, right?
Yeah,
And it
yeah,
gives me an underline that said, I can click a button in Visual Studio Code and it shows me where everything's allocating, right?
all right.
Those kinds of analyses would be done by JET, and then the VS Code developers would enable, like, oh, here's how I'm going to show you that information within VS Code, right? So the actual language server is invisible to most people, but you just see it as, oh, my IDE got better, right?
Yeah. But I guess at this point it's not shipped as default in the typical extension, right?
Oh, it's not even integrated into VS Code right now, so like it's a bit far off, right? So
right.
yeah, so again, it needs a bit more development in VS, in Google Summer of Code positions. It needs to actually get integrated into VS Code. It needs to get turned on by default. It needs to be shipped. All this extra stuff. So you won't see any of these advancements for a bit, but I think it's a nice announcement to say, hey, look, this is in the pipeline of things.
Yeah. And do you know whether the Google Summer of Code possibilities are happening there, or like can students now apply to this, or
Yeah, students can now apply to Google Summer of Code, right? So it's all open right now. I believe that the deadline is about 2-3 weeks away from now. So maybe when this episode goes up, it might be past the deadline. But yeah, I mean, if you go to the JSOC tab, you'll find that I think inside of here, the projects page, right? You'll find all sorts of projects, and I believe it would be baked under the tooling project. Yeah, so here's this tooling project for development of a new language server, and it's still up because there is the new language server, but now there's a lot of passes that need to be added to it. Right, every pass for calculating whether a function is type stable, calculating whether a function is allocating. All these things just need to be added to this new basis. Yeah, there's also lots and lots of other Google Summer Code projects. So if you're interested, get in touch.
Exciting, cool. Let's hope that someone will implement all these things. I'm very much looking forward to this.
Yeah, I mean, so there is someone who is really dedicated to this project, right? So it's the developer of JET.jl, Shuhei. He's the one that's kind of driving this, right? And so Shuhei is continuing to work on it. We at least got Shuhei involved, but I mean, this is a pretty Herculean effort. Kind of want to get more people involved, so that's why we're trying to get more advertisement to what's going on there, trying to make it so that way more people know what's going on, because maybe someone will find it cool and join the project.
Yeah.
Alrighty, so the next one is C codegen considered unnecessary. Neat example by folks at Julia Hub to compile new compile to binary capabilities introduced in Julia. So I'm part of this team, so I know this one pretty through and through. There's an archive paper that we put up. We actually gave this as a talk at a ModCon conference, so a conference up in Sweden, where a lot of industrial players like Saab and such were also speakers as well. And the title and the first line is supposed to be it's tongue-in-cheek, facetious, but also true. I'm just going to read it verbatim just because I spent way too much time on this line. Since time immemorial, an old adage has always seemed to ring true. You cannot use a high-level productive programming language like Python and R for real-time control and embedded systems programming. You must rewrite your. We present a counterexample to this mantra by demonstrating how recent compiler developments in Julia make Julia do everything. Right. So what does that mean at a high level, right? Well, so at a high level, people have always kind of thought like, okay, you have programming languages that, okay, so there's a 2-language problem, right? You have fast languages and you have slow languages, Python versus C, right? That's something that we've always talked about. But then there's also like the whole 2-language problem with, things that you can run on your computer versus things that you can run on your embedded device. I think, what was it? One of your JuliaCon talks, you talked about like, you want to run it on a washing machine, right? But that's real, right? Every washing machine, like, when you're in your car, your car, like these days, you don't have a manual crank for your pulling your seat back, right? You push a button up and your seat goes back, right? That has a microcontroller in there. Someone had to write the code for that microcontroller, and almost all of that code is written in C, right? So you tend to have this kind of thing going on where people tend to prototype algorithms in Python and R and MATLAB, and then you tend to rewrite it in C, so that way you can then put it onto these real-world devices, right? This is not for performance. This is because you need to have a binary that's shippable to an embedded device, right? And oops, well, I guess the HTML is supposed to be pretty nice. And what we're basically showing here is that, we thought we had the Jeff Besenson on as one of the guests a while ago. He talked all about this Julia C, right? What we're able to show is we're able to use Julia C to be able to take Julia functions and then just compile them down to small binaries and put these binaries on Raspberry Pis and other ARM v8 devices, and then actually run them as live controllers. So, they're software-defined PID controllers that are then be able to put into the environment. They're able to then put Julia into this embedded world, right? I'll still say that there's still some major limitations here. The size of the binaries and such are reasonable now. I mean, we're building these 1.7 megabyte binaries that are going on controllers, but the key limitations. Let me see if I can highlight this in here. I think the key limitations is we need to make sure that we can target different operating systems and chips, right? So the larger amount of the Julia runtime that you use, like if you use allocations, if you use printing and I/O, the more of the runtime you have to use, the more the runtime needs to be targeted to the device you're working on. And we don't necessarily have every real-time operating system and all these things in the target list. But we're able to show that ARM v7 real-time Linux is like hey, we could ship to that and things like that. So there will definitely be a lot of work in the near future for bare metal and RTOS targets, and there's actually some folks within Julia Hub that are already trying to hit those. But yeah, I mean, this shows that Julia is breaking that barrier now of being a high-level language, but also shippable onto hardware.
Yeah, that's pretty cool. So, but I guess the compiler has not shipped yet. So when we're recording this, the 1.11 version is still the officially released version, and I think the compiler ships with 1.12, right?
Yeah, so this is a feature of 1.12. It's in the pre-release versions, the nightly versions and such of 1.12, but yeah, it's not shipped yet. So I mean, hopefully, I don't know, 2-3 months from now or something, it should be the normal version of Julia, and then you'll be able to use this as a normal feature.
Yeah.
But we did make sure that like any PR branch that we're using here, they actually got merged into actual 1.12. So it's not like it's this fake, voodoo demo of like, oh, we can do it, but you can't. It's like you can the moment 1.12 comes out.
All right. Yeah, that is something that is definitely accessible in the sense that, I mean, it might not have been yet released on the Julia app, or it might be available via Julia app via the nightly channel, right?
Yeah, well, I mean, on the nightly channel, you'd be able to use it. Yeah, I mean, I will say on the nightly channel, nightly because it's nightly, right?
Yeah.
You tend to get different sizes of binaries. It fluctuates up and down. They're working on better CI and stuff for that. But I mean, for 1.12, because this is such a headline feature, they will be checking that the 1.12 doesn't have a regression in this. So, but I think that the release candidate for 1.12 isn't cut yet, so you can't tell Julia C. Or Julia up, like, oh, give me version 1.12 art release candidate, right? I think that should be happening in like 2 weeks or so.
Yeah, wow, that's really exciting. Yeah, I mean I mean, just having standalone is already pretty big, but then being able to show that it's on the embedded devices as well. I mean, this is huge.
Mm-hmm.
Run Julia.
Yeah, you said you wanted to run it on your dishwasher or your washing machine, and there you go.
Yeah. Really cool.
So the next topic is the @threads macro can cause normal-looking Julia code to have somewhat confusing behavior in an edge case, redefining variables in a newly defined enclosure, and the way that boxing variable work breaks up the mental model of a variable is just a piece of data. It's a pretty esoteric source of bugs, and now a possible fix and warning has been proposed. Yeah, so this one is a bit in the weeds. There have always been a few behaviors that are a bit odd with some closure or emboxing, right? I mean, there's been this kind of edge case where, like, okay, if you have a closure and then you're boxing into variables, in some cases it's not able to infer, right? And I believe that this is kind of related to one of those cases where if you happen to be in one of those cases, then in some cases multi-threading is losing some optimizations, and that has some major to do with performance. Now, I know it's a racing condition, so it should be able to do something about the accuracy. That is a bit that don't know too much about. But what I do know is that there's something in the weeds there. I've never hit this myself to kind of know this well enough, but there are some suggestions now which should be merged in the near future that will give better warnings for if you're hitting this behavior, so that way you can know and be able to make sure that you don't hit this race condition.
That's cool, yeah. And I mean, multi-threading is always a little bit of a pain to work with, but having additional support with all difficult things is always nice to have, yeah.
Yeah, I mean, also some multi-threading is always difficult to work with mutation, right? It's easy to work with immutables, right? And so what's really kind of going on here is that when you box something, right? So when you have something that's uninferred, the way that is kind of handled is it's like a pointer to memory, and it's putting the thing in memory, right? So like these the way that like the native representation of uninferred variables is just, I know where this pointer is, and the pointer points to something, right? But this is one of the big things that leads to the memory, or the major difference in performance is that pointers are pointing to something on the heap rather than the stack, and the stack is more local to a function. So a stack is local to a function, whereas heap memory is accessible outside of the function. But importantly, heap memory is accessible to on other threads, right? So when you have shared memory parallelism, heap memory is shared between threads. So what that means is that like the variables, like if you say a equals 2, b equals 2, a plus b inside of a function, that's function local, right? Because it's on the stack, and the stack is function local. But the arrays that you write to and create within the function are heap, are dependent on your heap. And every thread actually touches that same heap. So in a different function, you can basically say, hey, I'm going to start editing this array, right? And that's actually used all the time in multi-threaded arrays, right? You kind of take a big array, like in BLAS, right? You take a big array and you do multiplication in different parts, right? The issue that goes on here is that if you take a scalar and now it's not type stable, you put it in a box because now you don't know what type's going to be in there, but the boxes are mutable. And so boxes now have this kind of different behavior because it lives on the heap. And so you need to make sure that in different threads, you're not modifying the same box. And there are some cases that specifically with closures, yada, 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 that can hit this. But now it turns out that there's better ways to be able to warn for this. So, okay, the next thing is PKG now prints if precompiled and loaded versions of a library are mismatched. Frequent source of repeated compilation and updating packages. Yeah, I mean, I think that this is something that a lot of people didn't realize was going on. And so I just love this. Like, so let's say you did like, if you did using so like you said, did using ordered collections, and then you like added a new package, right? Then if you already have this inside of your library, like you will already have loaded something, and so it'll have to precompile, and then in your next Julia session, it'll actually recompile because it will not have precompiled to get rid of the stuff from the version 1.6.3, right? It'll compile everything in your current session to be using what you've already loaded, because it doesn't want, whatever you have in your REPL still has to work. But in your new Julia session, you'll then have this next version that you will have just added, and it'll recompile all your libraries to that. And it was very silent. I think a lot of people just open up the Julia. It's like, it's pre-compiling all the time. And it's like, oh, that's because make sure you haven't using a bunch of packages before you add packages, right? Like that was like a mantra I had to mention to people on Discourse, but because it was completely silent, the package manager didn't tell you that you shouldn't be doing this. People just got a lot of extra pre-compilation. And now you get a warning. You basically get this, hey, look, there's a different version loaded there. So sometimes all you need is a message, right?
Yeah, that's true. Yeah, and I think that definitely happened to me as well. Yeah, that is something that a lot of people just stumble upon, and
it's objectively confusing, right? Because I mean, there was no message about it,
yeah.
And so I feel like people kind of learn their own like little voodoo of like, oh, the way that I update packages is I always do it through VS Code, and I always like people always have come up with their own way of like, here's my way of updating packages that works very well. But I think most of the reasons for that voodoo is because this thing about having a package loaded.
I got less precompiles when I added packages on a full moon, so.
Okay. Yeah, that is a good one. Yeah.
Yeah.
All right. Compiler.jl. The Julia compiler is now factored out to as a standard lib so that you can experiment with it. And it's getting a best practices document. I think that this is this is kind of for nerds. I think that not so many people are really like hacking things in the compiler, but I think that what you'll actually see from this is you'll be able to see a lot more development that's able to happen a lot faster, because as we mentioned at the beginning, right, Revise is one of these things that can really accelerate the way that people are developing Julia packages. But now the compiler itself is refactored out to a package, and so I believe you should be able to work with it with Revise and do all sorts of like standard Julia tricks on it. I think most people are not going to just suddenly become a compiler developer, right? But for people who are compiler developers, this should make it a lot simpler to be able to, create small changes and, not have to wait for the next Julia release and and be able to run the CI independently and all that kind of extra fun stuff.
So I think this is very exciting, because I remember Kino's talk from last JuliaCon, where he said essentially all you need is the multiple dispatch implementation, and you almost have the entire Julia core system available.
Mm-hmm.
But it's not clear from the main Julia repo where all those bits and pieces are located, because it's so much intertwined with like the manual nitty-gritty stuff that needs to be implemented in C. And now having this dedicated location, it's another layer of peeking under the hood that gets accessible via this.
And I think also getting a best practices document will be a big thing
Yeah.
for it too, right? Because it's not just sectioning it out, but it's also saying like, hey, look, we actually want to guarantee some interfaces on here. We want to document how some of this works. We want to keep some of it alive. And, before it's always going to be like, oh, well, the compiler's internal and things could change. So, go talk to Keno if you want to know this part of the code, right?
Yeah.
And when it was changing fast, right? In Julia 1.0 and stuff, I think that makes sense. Like, it's just difficult to get into a live project like that. But now it's kind of hunkering down. And then the big thing is a lot of other people want to write extensions, right? A lot of automatic differentiation libraries and these kinds of things are writing extensions to the compiler. And now it's saying like, okay, let's define our interfaces, let's define our API, and let's make sure it's easily targetable, and all those kinds of steps are now being taken.
And it's also from a developer perspective, in particular in open source, right? So it's a thin line of documenting everything, both like a user and a developer manual, all the time, if you know that what you're currently working on is fast progressing and you expect that there will be so much progress that it doesn't make sense to keep up with the documentation, because it will just be a lot of wasted effort if there's a lot of breaking changes coming in the near future. But at the same time, if you do not keep up with this, the chances that things diverge are so tempting, because I mean, it's always more fun to make progress on the actual problem than just documenting what has been done. And so there's always a bit of a danger to get out of touch with what's documented, and then if people want to dive into it newly, they need to retrace all those steps. But then having these snapshots in time where it's like, okay, we're not pretty certain this is going to be stable. This is how it will look like in the near future, for the foreseeable future. And then this is also a good point in time where newcomers that are interested have the right. It's the right time to dive in, because now it's going to be okay.
And I think that the compiler will always have a few zones that are like, there be dragons over here, right?
Yeah.
But I think that it's good for people wanting to build AD libraries and stuff to kind of really know there are dragons right here. This is what we expect to be stable, right?
Yeah.
Because if you're like, okay, I need to figure out how I want to use this. Do I use this function or do I use this function? If this function is documented and has a stable API, this function looks like maybe it runs a little bit faster, but you're like, I don't know about it. Now you're able to kind of know, like, okay, we're being told use this function, just use this function, right? Like the extra second or whatever compilation, we'll deal with this later, like but let's make sure that things are correct and stable and stuff. And so I think that the practical benefit that you'll tend to see is that things like Zygote and Enzyme and these things will probably just get more stable in the near future because the backbone that they're building on is becoming more stable. Right, and then more caching capabilities for Julia code running through customized compilers and abstract interpreters reminds me of a bigger backend of integrating external compilers. Yeah, I think that this piece right here, I think that a lot of this is specifically things that we kind of talked about with Enzyme, right? So like again, these automatic differentiation libraries do abstract interpretation of your code, right? They basically run your code differently. And the issue is that we built up all these tools for doing code compilation, right? To be able to version 1.9, fix a lot of the first time to first plot and everything. The way that it did it is it was able to store these binaries and cache this code, right? But then you have these alternative compilers, right? So GPU compiler is one, but Enzyme is actually built on GPU compiler. So Enzyme uses GPU compiler. Like GPU compilers, like more of like a alternative static compiler to Julia. It's a more static-y compiler, so it's kind of a misnomer to call it just GPU compiler at this point. But like so, GPU compiler, is what Enzyme targets, and I think also, Mooncake is a different AD engine. I don't know if it hits GPU compiler, but you have these other types of compilery things going on that again are kind of hitting different parts of the compiler. And most of those just don't benefit from all the time to first plot fixes because the code that it comes from Enzyme, it's just like, oh, we don't know what to do with this, so we always throw away the compilation, right? So that's one of the big reasons why you see that automatic differentiation can have a longer time to first X, because it's just none of the automatic differentiation code none of that generated code is cached, right? And I believe that the main purpose of all this was just to be able to make it so that way abstract interpreters can tie into the code precompilation thing. So you could, say not just precompile a function call, but also do enzyme auto diff on that and have it precompile that and save the generated code from that. I believe cool. That's the core of what Valentine's stuff was, and I don't think that all of that is in yet. At least I don't think I've seen all of it yet, but there's this kind of push to make it so that way, Enzyme in particular, right? Because Valentine and is kind of involved in this, and also Billy and some of the Julia Hub compiler folks have been kind of talking with them on it. So this is kind of in this push to try to see like, can we make it so that way automatic differentiation gets all of the precompilation benefits that we have for everything else.
That's cool. Although I have to say, typically when you use automatic differentiation, this means that you're running a long optimization anyway. And so I'm guessing the time to first X is not as big of a problem for the long computations. But of course, for prototyping, this is like once the job runs on the cluster and you know that it'll compute what you want it to compute, then everything is fine. But the fast iteration debugging loops are definitely helped by this as well.
Yeah, and I think that's why this kind of is coming. A few releases after the time. Because remember, Valentine was also the same. Valentine is both the person who created a lot of. Valentine with Tim did a lot of the work for the precompilation binaries, right? And Valentine also happens to be the enzyme developer, right? So there's a connection between them. But he didn't it wasn't a requirement that we don't release this feature until automatic differentiation can do this, right? Because it's I think the first thing was like, why the heck does it take 30 seconds to load up a plotting library? Because this isn't actually doing any real computation, right? Like that was the first issue to solve before, okay, now we have some things that are doing some real computation. Can we also try to store as much as possible? Because this is just annoying, right? It's more annoying at that point than it is like a make or break kind of feature. And then let's see. So deep rework and cleanup for IOBuffer. I have to say I'm not the biggest IOBuffer user. So IOBuffer, right, is the underlying thing that's used all the time in IO. So like printing and reading from files and everything, right? And there's a pretty big change that's going to be happening to it because there's a lot of implicit invariants and a lot of assumptions inside of there. a lot of people just want to make it so that way it fixes a whole lot of bugs and makes it a lot nicer to use.
So everyone working with files should just have the feeling that this now works smoother, I guess.
Yeah, I think it just ends up being a big set of bug fixes and less brittle code. So it's more of like a. I do know that there's something to do with some performance improvements. Particularly, there's something to do with when you have non-dense memory. So if you have like these scattered memory kind of reads, so special files and things like that should be better. But I haven't heard that in the normal case. I don't think that you'll get the biggest performance improvement, but there'll be a lot of bug fixes to it though.
No.
In case you didn't know, besides the subtyping operator, we also have a super typing operator comparator, and that can be used in type parameterizations, and now has a little bit more syntactic sugar support. Well, this one I actually didn't know about. So you can just kind of use it so that way you can, like greater than is greater than. Okay, that's not the biggest feature, but it's kind of cool, I guess. Yeah, so this T has to be something that is. Yeah, T has to be something that both is a number, but also is not an integer. That's a funky one.
Essentially a float, I guess.
Yeah.
I'm sure there will be use cases.
I'm sure there'll be a use case for it. I think for me, this is kind of like I haven't had to use a chaining version of super type operators before, but I mean, someone must have needed it.
I mean, we can do it, so
I'm sure I'll find a use case for it at some day, and I'll be like, oh, this is an essential feature. How do we ever use Julia without this? So this is actually best practices for documenting return types. I don't think this is not merged yet, but there has been things. So basically, right. Return types were a feature that were added right before Julia version 1, but they're kind of in an odd place because return types aren't necessarily like a compiler level feature. I mean, the way that they actually work is they just add an assertion that the type is correct to the end of a function. So they actually don't take place. They don't actually take place in dispatch, right? So like this right here creates a new dispatch, but this thing over here doesn't actually interact with dispatch. It's more just an assertion that if you didn't get an abstract vector on the end, it would throw an error, right? And so I think that some of the documentation is just trying to highlight that if you're trying to use this for dispatchy kind of things, or if you're trying to use it in these ways, it's not going to really do what you want. So here's like some correct ways you should be thinking about using it.
And so, I mean, if you enable the assertion, does this help the type inference engine?
It doesn't really, no. At least not in most cases. And well, it doesn't do anything different than if in the last line of your code, if you say like convert to integer, X, right? It's the same thing as that, right? And if you can't convert to an integer, then it throws a conversion error, right? Okay. And so what could happen is that you have a whole function that's like kind of type unstable, and then at the very end you say convert to integer X, right? And then what comes out of this line has to be a integer, and now you return it. So now we are able to infer that your code is an integer, right? So it's not really doing anything different from what you could do in your code, right? But it is a way to be able to, if you do put it as a concrete type and you do a conversion to that, then then you're pretty much guaranteed to have inference work out, and that can make it so that way down the line, the functions that then rely on that return type can make use of that information. Though again, it's kind of lives in this funky space because it's not really a part of dispatch. It's a part of assertion, so it's not really in the compiler in the same way as the type specialization what comes in. So I think that it's just like there's a little bit of like documentation, and also for weird cases like how do you document return types of closures and things like that. There are some cases where I've always had to look it up in the documentation. I believe this clarifies it a bit more. So binarybuilder.jl is stuck to Julia 1.7. Oh, I didn't know that. Work has started to removing these constraints thanks to stabilities and guarantees in PKG internals enabled by recent work. So binary builder, if you don't know, binary builder in YGT is this kind of whole setup of sending you binaries as part of packages. So package developers can say like, oh, I have this binary, like for example, sundials. This is C code or C++ code. So I want to have precompiled versions of this sundials, and then when you add sundials.jl, it sends you this binary along with it, right? And so the way that we do this is, some things like Python's wheels require that you have compilers installed on your computer, and if it fails, you have these big compilation messages and everything, right? The way that we found it to be most robust in Julia is we have a system called YGTeacherSil, which it runs a virtual machine. It compiles the binaries for pretty much every operating system you want to have, and just stashes all these binaries. And then when you install a package, it downloads the binary for your operating system, right? But I guess that binary building system has been on version 1.7 for a while. And it must be due to some really core things inside of PKG, because the binary builder system is doing some wonky things with virtual machines and all sorts of things, right? So it seems like they're trying to work that out so that way they could do a version bump to that. I'm actually surprised it's been able to be working on version 1.7 for so long and be able to build. But I mean, since its output is really just like these binaries of C code and binaries of C++ code, I guess it's been totally fine that you have to boot up an ancient version of Julia. But
I also seem to recall that there was a talk about Binary Builder 2 at JuliaCon from Elliot Saba, I think.
Yeah. Elliot had a version of Binary Builder 2, but I think it's going to be like a 2-3 year effort. So maybe. I don't know, maybe that's kind of a thing where it's like, okay, can we get the current binary builder to be bumped to this LTS and not have to wait for the next binary builder?
Yeah.
But yeah, if you want to know more information on all this cool stuff coming with, potentially binary builder 2, like, I don't know, 2-3 years from now. I don't think he put a timeline to it, but I think it's like, I put a long timeline like that. Go check out Elliot's video on binary builder V2. Let's see. So the internal support for LLVM 19 in the Julia compiler is done. Progress is being made for LLVM 20. I think for the most part, I mean, these kinds of changes to most people will be kind of invisible, right? Like some better compiler passes can happen. It'll change your compiler times. It's not always that it actually gets faster with each version. Some things will get faster, some things will get slower to compile. But I mean, it's necessary work to kind of keep it up to date. And it's always a pain. And so, yeah, like versioning of LLVM is always this funky thing because the LLVM that's always shipped out is not necessarily robust to all the numerical behaviors that Julia tends to do. So Julia tends to keep a version of LLVM that is patched, and it has all these LLVM patches that it kind of ships with you. And that's why actually with the Linux package managers, right, you always, Linux package managers can give you a wonky version of Julia because it just ships with you like, oh, on your system you already have LLVM. Let's just use this LLVM. It's like, no. We have this patch so that way, the sign function is numerically correct. We have this patch, this patch. Over time, the packages getting smaller and smaller. But yeah, that does mean that each time that there's a major in LLVM, the Julia LLVM needs to be bumped, and then all the patches need to be updated to that as well. Yeah. So we always stay a few LLVM versions behind, but I guess we're back up to 19, but we're not on the 20 yet.
So as someone who understands very little of the LLVM ecosystem, do you think it will ever be valuable to try and rework a LLVM kind of backend in Julia to remove this dependency?
I don't understand what we're saying with that.
So LLVM is this enormous effort that pays off in compiler construction, right? Mm-hmm. Which makes it both a huge asset, but also a certain liability in that sense, right? So the Julia ecosystem is tied very closely to LLVM, and of course, I mean, it being open source, you can always say, okay, I'm gonna stuck with the version that we have, and if LLVM goes off the rails for whatever that means, we do not have to follow it. But at the same time, the question would be, would it be nice to have a backend that is purely in Julia, just because we can?
Well, I mean, so okay, I think I see where you're going for now. I think that the issue is, let me see if I can give a better understanding of LLVM in like a very simple way. LLVM is essentially a chip-independent assembly language. Right.
Yeah.
So when you think about assembly language, there isn't such a thing as just like, oh, this is assembly language, right? There's assembly language with certain commands that only exist on x86 chips, and there's commands that only exist on ARM chips, and there's commands that only exist on. So if you actually are to write an assembly language, you have to write assembly language that is in a chip-dependent way, right? And that makes it kind of, so the C compilers, right? GCC, for example, like they take C code to assembly language, but then they have to have a different version of the compiler for every single new chip that comes, right? LLVM, though, because it is basically this layer that sits above all the different chips. It's like an assembly language that knows how to, be able to take this low level and then be able to send it to, oh, you want x86 here. Oh, you want GPUs like, .ptx. Oh, I know how to generate code for GPUs, right? I know how to generate code here. And so because Julia targets LLVM, that's how we're able to support, all these different chips. And this is actually pretty important because these days, because, for example, one of these MacBooks, right? M series MacBooks, they're not x86 chips, right? They're these ARM chips, right? And so there's kind of a different, you'd have a completely different assembly code for MacBooks than you would have for, your AMD and Intel computers. So I think, with that understanding of it as like being a chip independent assembly language, it's like, oh, it actually makes a lot of sense as a work saver to make sure that we support that, right? Because otherwise you're writing assembly language to here, and then you'd have to do it for every single chip, and you have to it's a pretty Herculean effort to do it for each new device.
Yeah, that's true. I'm that kind of nerd that likes to think in the theoretical possibilities, right? And having a self-hosted compiler or like a self-compiling compiler is just something that, from the pure computer science perspective, has a certain appeal of beauty, right?
Yeah, that's some utopia stuff. Yeah, I don't know. I mean, you can have a self-hosted compiler without with still having LLVM on the bottom, right? I mean, maybe you wouldn't call it a self-hosted compiler, but I mean, like you could have a compiler stack that's Julia all the way down, right? But what the Julia compiler does, it's Julia all the way down, but it takes in Julia code and it spits out LLVM code, right? That would still be a self-hosted compiler, and I believe there are versions of Rust that do that. I forget whether Rust is all LLVM or not, but I believe
so
it is.
I think Rust has a LLVM dependency, right?
Yeah.
So
Rust would be a self-hosted compiler that targets LLVM. So they're kind of separate ideas. But yeah, could you get rid of the LLVM part and just have Julia code that's doing the targeting? I mean, you could, but then each time that like, oh, hey, a new AMD chip came out, and like this new AMD chip has like a new vector SIMD support, right? Then someone would have to come in, and you wouldn't be able to support that chip until someone adds that, and that becomes a lot of work. And to this point, like LLVM is so baked into the industry that people from AMD, Intel, and ARM and these chip associations, they are actually the ones giving the contributions to LLVM. Basically say like, oh, I have these new features, here's how you target them, right? They do this through LLVM, right?
Yeah.
And so we would have to figure out and recreate all that work. I just think that in 2025, LLVM is just a part of LLVM is kind of like the new assembly language. I think that's probably the way to put it. But yeah, I do think that, I mean, there are some things that can happen where like, okay, LLVM, because it is this kind of assembly language, there are a lot of compiler passes written there. So like, do we need to use all the compiler passes written there? Well, the lower you go in the compiler stack, the less information you have. And so things like, Julia's inlining that. So right, whether you put a function inside of another function and delete the function in the way it's actually compiled, that's actually all done at the Julia level, because at the Julia level, we have more information about how long we think the functions are going to run. So our inlining passes are better than the LLVM ones, right? And so I think over time, you'll probably get more and more compiler passes probably lifted up to the Julia compiler. Especially that's one of the reasons for this compiler being factored out, so that way more people can write customized compiler passes. But you'll still have LLVM, I think, for eternity, just because it's just the way to be able to target chips these days.
Yeah, that's true.
Yeah, and support for using various external garbage collection algorithms is growing here and here. So this is another thing, right? So not only does LLVM have, like assembly language kind of thing, but there are also garbage collectors written for LLVM as well, right? So where were these? Yeah. So I think that a lot of these things are trying to tie into things like MMTK and these other compiler paths or different types of GCs that are LLVM level GCs that are kind of you essentially get them for free by being built on LLVM. It's not actually free because you have to make sure that your allocator is giving the GC the information that it needs to be able to run. But Julia is getting a lot of so MMTK is the one that's gotten a lot of work, especially by the people at Relational AI. And so basically what it would be able to do is the moment that that it's targeted on enough, we could be able to turn on these external GCs and be able to see, hey, does this GC work faster or slower? I don't think it's going to be like a straightforward like, no, this GC is just faster. Let's do this. It's more about every GC is making trade-offs, right?
Yeah.
So on this code, it might run faster. On this code, it might run slower. This GC might give slower run times, but it might be able to better cap the GC pauses, so it's better for soft real time systems, and so there's a lot of different ways that you could tune a GC, and so being able to use these different garbage collectors would be good for being able to test them out and be able to choose one that's appropriate for given scenarios. I think that the MMTK one was the one that a lot of people seem to be looking at as one that can just be a new default garbage collector, just because it tends to be pretty good around the board. Whereas then there's some other ones that are kind of targeted like soft real-time scenarios. So you can see it's just all very low-level LLVM type stuff. But hopefully in the near future, MMTK could be tested out as potentially the new garbage collector. And the way that you see that is if you have allocating code, your allocating code just wouldn't have as much of an overhead from the allocations. So I think that's like the core of like the what's new in Julia, and it's very focused on the compiler rather than the package ecosystem this time around. I think I think that there are some ecosystem developments, right? So one big one is that Colab now supports Julia, right? There's a screenshot in here. Where's a screenshot of it? I think that someone had it on someone had a screenshot of how it looked like on Twitter, right? But yeah, I mean, so Julia's just directly there inside of Colab, and so you can tell it use the Julia kernel, and you write Julia code. It actually has a lot of Julia packages already installed. I think that Plots is already installed, Maki is already installed, so they're already installed and precompiled in there. In fact, Enzyme with Reactant and Lux is actually precompiled by default. And one of the cool things is I don't think we've mentioned Reactant at all on this podcast before, but Reactant's like this kind of specialized compiler thing that adds extra compiler optimizations to a lot of array-based code. So you think about it as kind of like a JAX, but works directly on Julia code. There's no kind of tracing or no special handling required. There's a bit of tracing, et cetera, et cetera. Details we should probably have Alvik on sometime to talk about Reactant. But one of the nice things with it, so this alternative compiler, is it can actually target TPUs, right? And so there's demonstrations on Colab of actually, Julia, like just Julia linear algebra code, and Julia Lux code with Reactant, then targeting Google's TPUs directly on Colab. So yeah, I think it's a pretty nice announcement. I just use a little bit of Colab myself just to be able to show some demos with DiffyQPy, because it was a nice platform. So I think that for like documentation, if you want to give someone documentation and say, hey, now run it yourself with a click button, it's very nice for doing something like that. Let's say composable async status for progress reporting for multiple independent potentially stat. Oh, so this is so there's now a package that makes I guess that's in a Slack. I guess if you have to do a bunch of printing from asynchronous code and such, that must make that a bit better. RxInfer got version 1, so RxInfer is a message passing Bayesian inference package, kind of like it's a competitor in some sense to Turing, but they kind of work differently, so they have different pros and cons. And it got to its version 1.0, so now it's a bit more stable. Academic identifiers. Oh, I haven't seen this. Okay, so structured types for dealing with archive citations and such. It must come into play in some of the documenter work. An in-depth discussion behind details of abstall and realtall. I didn't know that we did that. Okay. Oh yeah. So the definition of absolute tolerances and relative tolerances in ODE solvers is it's not as trivial as you think it would be, because it has to do with local tolerances. I'll leave people to read that if they really care. Some of the GUI tools got a bunch of improvements. Mach-E was used for neutrino physics, so it's got some nice improvements. The iTensor team, right? So a lot of the team that does a lot of I think that they're based in the Flatiron Institute, right? They got a whole bunch of new packages for their quantum algebras and quantum operations. And the terminal system monitor. So I guess something like ATOP now, or HTOP now, built directly into Julia. So
hold on a second. So the Mach-E being used in the particle physics announcement, neutrino physics discovery, would probably also entail that Julia was also used in the computations behind the neutrino discovery, right? Because I'm guessing they had to do a lot of data analysis for these particle physics detector rare event.
Yeah, and it looks like, if I just search .jl right in there, I guess there's a Julia library that comes right up for some of the CUDA accelerated Monte Carlo simulations and such. So yeah, it seems like it had I can't tell you how big of a part it had in it. I don't know the people that involved in this, but it did seem to have at least a substantial portion. And a lot of the plots were Mach-E. So not surprised the plots were Mach-E. Mach-E just looks beautiful, and a lot of the plots here look beautiful. So in the abstract mapping, Metroids, tensor algebra. I think this is now kind of getting to the bottom here. So I think that's like a lot of the major updates. I think that a lot of those are also touched upon in the Julia Hub one, right? The Julia Hub one also mentions the collab announcement. There's a lot of doubling down that's going on in terms of pharma work. So pharma is one of these domains that has been getting a lot of Julia adoption, and there's been a lot of videos coming out from both the pharma and Julia Hub about how these integrations are working, and a lot of conference docs. So you'll see a lot of Julia at a lot of these. There's a lot of talks that are going around now on especially the way I talked about with the compilation of C code, showing how that can be used in industrial domains, and mixing that with a lot of the SciML tools for controls engineering. Right, there's a lot of talks that are going on at controls engineering conferences, aerospace engineering conferences, and you'll see a lot of folks talking about these new binary features how they're being used with that. And also our podcast got a mention here. So. So yeah, and then also there's also someone in Julia Hub that just takes a huge list of every blog post that comes out. So you might want to check this out if you're like, oh, where is Julia mentioned in the news? Like every month they collect all of the things here. I don't think we have time to go through every single new blog post, but yeah, I think every month there seems to be like 40 new blog posts about Julia programming and stuff coming out.
Shouldn't these all also be featured on the blog page of Julia Lang?
So the Julia Lang blog, the Julia Lang blog is not really a feature page. It's more like if you do a pull request to the Julia website, you can add your own blogs to this. So anyone can add a blog to the Julia blog here, but yeah, some people just prefer to write on Medium or on their own blog and such. So yeah, there is a service, if you haven't heard of it yet. There's a Julia Bloggers. It's a blog aggregator, and so if you subscribe to this RSS feed, you'll just get everyone who's added their RSS feed to this, their blogs all end up there. And so this is a nice place to find tons and tons of blog posts on Julia as they're coming out, daily. Alrighty, I think that was this month. I think we got some cool content out of that. I would like to do this one again.
Yeah, let's definitely do it again. And I think also my impression was that February was a good month for things to happen.
It was a very compiler-y month. I think some of the updates are a bit more focused on the package ecosystem, but this one, the reason why it's very compiler-y is because this is kind of gearing up for the version 1.12 release, right? And so everyone's trying to smash their latest compiler feature in before the feature freeze. And so so I think it ends up being very more in the weeds here, but hopefully people can understand what exactly to expect in the near future versions of Julia.
Yeah. Looking forward to a release candidate soon.
Yeah. It should be like 2 to 3 weeks. I'm going to throw it out there and it's going to be completely wrong.
I guess this is the end for today's episode.
Yeah.
I'll thank you, Chris, this time for taking the time and explaining the nitty-gritty details to me. And
no worries. Yeah, I didn't shave this before this episode, so I got the mustache of an expert for this one. So for the next one, I might shave, and you might have to do the explanations.
All right, and then see you again in the next episode.
See you on to the next episode. Ciao, everyone.
Ciao.